Unit 4, Section 11.5, Worked Examples. Find the indicated probability. If probability A or B equals 0.6, probability A equals 0.4, and probability of A and B equals 0.35, find probability of B. The formula for probability of A or B is probability of A or B equals probability of A plus probability of B minus the probability of A and B. We can use the given information to solve for the probability of B. So I've taken the information that was provided and put it into the formula, and we notice that the probability of B is on the right-hand side, which is what we want to solve for. So we can combine the like terms on the right side, and we have 0.6 equals 0.05 plus probability of B. Subtract 0.05 from both sides, and we get 0.55 for the probability of B. We can go back to the original formula and check and make sure that that's correct by putting in all four quantities and making sure that we get a correct equation, which we do right down here, so we know that that's the correct answer. The manager at the local auto shop has found that the probability that a car brought into the shop requires an oil change is 0.66. The probability that a car brought into the shop requires brake repair is 0.34, and the probability that a car requires both an oil change and brake repair is 0.13. For a car brought into the shop, determine the probability that the car will require an oil change or brake repair. Let A be oil change, event A be oil change, and event B be brake repair. We know probability of A equals 0.66, probability of B equals 0.34, and probability of A and B equals 0.13. We want to find probability of A or B. The formula for probability of A or B is shown here. For our problem, we can go ahead and put in the numbers that were given in the problem, and I'm going to pull up my calculator and we're going to go ahead and solve for the probability of A or B. So we're going to take 0.66, add 0.34, and subtract 0.13. So the probability of A or B is equal to 0.87. Suppose you draw a card from a well-shuffled deck of 52 cards. What is the probability of drawing a 2 or a queen? Are the events of drawing a 2 and a queen disjoint? And they are. There's no card in the deck that's both a 2 and a queen at the same time. So what formula should we use? So if we go back to the probability formula for probability of A or B, what's going to happen here is this portion here is 0, so we won't have to worry about that when we do our calculations. So in our card deck, we know that there are 4 2s, 4 out of 52. There are also 4 queens, 4 out of 52, and we get 8 out of 52, and we have to simplify the fraction, so we see that both numerator and denominator are divisible by 4, so we get 2 out of 13. What is the probability of getting either a heart or an ace when drawing a single card from a deck of 52? Are the events of drawing a heart and drawing an ace disjoint? These events are not disjoint because there is an ace of hearts. So when we use our formula, we will have a probability of A and B that we have to put into the formula. So the probability of A here, there are 13 hearts in the deck, so we have 13 over 52. There are 4 aces in the deck, so we have 4 over 52. And then, as I said, we have 1 ace of hearts, so we're going to have to subtract that. That's the probability of A and B. And so in my numerator, I have 13 plus 4 is 17, minus 1 gives me 16. 16 over, it's going to be 16 over 52. And both are divisible by 4, so I get 4 over 13. Consider a collection of envelopes consisting of 3 red, 3 blue, 3 green, and 1 yellow. If 3 envelopes are selected at random without replacement, determine the probability they are all red. Enter the answer as a simplified fraction. So we need the total number of envelopes, and that's going to be 10. And we're going to select 3 without replacement. So when we draw the first time, the probability of getting red on the first draw is going to be 3 out of 10. We don't put that envelope back in. So when we go back in, we've got 9 cards left and we've got 2 red cards left because we already picked one red envelope rather. And on the third draw, we've got 8 cards left and there's only 1 red card. So the probability of getting all three red envelopes is going to be 3 over 10 times 2 over 9 times 1 over 8. Now, it's simpler for me to go ahead and try to see if I have some common factors before I multiply because I do want a simplified fraction here. So let's take a look and see what common factors we might have here. So I can see that a 3 will go into 9 3 times, and I see that a 2 can go into 10 5 times. And so let's see, we've got 5, let's get our calculator. So we've got 5 times 3 times 8, 120. So this is going to be 1 over 120. So 1 out of 120. A sample of 40 people who recently hired an attorney yielded the following information about their attorneys. 3 people who provided information for the table were selected at random. Determine the probability that the first 2 would not recommend their attorney, and the third is not sure if he or she would recommend their attorney. What is the probability that the first 2 would not recommend, and the third is not sure when we pick those 3? So we're sampling without replacement. So when we pick the first person, there are 40 people in the table. And the probability that the first person would not recommend, we see there were not recommend was 9. So this is going to be 9 out of 40. We're not going to put that person back in. So when we go back in the second time, there's 39 people left, and 8 of those would not recommend because we're going to assume that we got a person who did not recommend on the first draw. And on the third draw, there's 38 people left. But we haven't picked anybody from the not sure group, and there were a total of 8 people in that group. So the probability of getting 2 who wouldn't recommend and the third not sure is going to be the product of those. So we have 9 over 40, and then we have 8 over 39, and finally we have 8 over 38. Now again, before I try to just multiply straight through, let's see if I have any common factors here. So I can take 9 and 39, divide each of those by 3, and I get 13 down here. And I have a 3 up there. I can divide 8 into 40 and get a 5. And I can divide 8 by 2 and also 38 by 2 and get 19. And then if I multiply across the numerator and denominator, I have, should come out with, oh, this is a 4 here. This is a 4. We divide it by 2. We have 12 over 12 over, my denominator is 12. 1, 2, 3, 5, and I apologize again for the pen here. So it should be 12 over 1235.